Okay, let's talk first of all about the objective of this experiment. And here you can see two different brands of washable markers. The question we're going to ask is, do these companies use the same compounds in making the ink that produces a certain color? So we're going to compare, let's say, the brown color from Crazy Art versus the brown color from Crayola. And we're going to ask the question, they're both brown, but are they made up of the same pigments? And to do that, we're going to use a technique of chromatography. So for the technique, let me get these out of the way. We're going to be using some chromatography paper. It's essentially filtered paper that has been cut into squares. And we're going to need a ruler and a pencil. And we're also going to need a 250 milliliter beaker, a small watch glass, which will serve as a cover, and then a special solvent made of ethanol, butanol, and ammonium hydroxide. And we're going to be flashing the composition here on the screen over the next few moments. Okay, let's start preparing the quote-unquote chamber where we're going to carry out the separation or the development of the chromatography. We have a 250 milliliter beaker, and then we have this developing or separating buff solution. And what I'm going to do is I'm going to take just enough and pour in enough just to cover the bottom of the beaker. I don't want to put too much, just enough to cover the bottom of it, form a thin layer at the bottom of the beaker. And always close this immediately. Don't forget, never put the cork stoppers on the bench. Always hold them in your hands. And you can see where there's just a little bit of it on the bottom. Now, because this has some fumes that might be upsetting to some, I'm going to use the watch glass to cover it. And I'm going to set it aside as I prepare my chromatography paper with my samples in it. Okay, what I have here is a piece of filter paper that's been cut in the shape of a rectangle, and I'm going to place it along its long side. The first thing I want to do is, before I load my samples, is I want to give all my samples the same origin or the same initial point. So I'm going to draw a line here. I'm going to start by using my ruler, and I'm going to draw it at 1 centimeter from the edge of the filter paper. Notice that I'm using a pencil, not a pen, because if I use a pen, what's going to happen is that I'm going to end up drawing the ink of the pen along with the pigments of my samples, and I don't want to do that. Okay, so there are my two dots. You can see them there. I'm going to now use the ruler to draw a line along those two dots, and that'll give me a point of origin. All right, again, notice a faint pencil mark that generates that. And since I already have one dot there and one here, I'm going to put in another dot over here on the same line and another one here on the same line. These are going to be the places where I'm going to be loading my samples. All right, so let's get the samples. Remember, we're going to compare the brown color of Crazy Art with the brown color of Crayola. And we're going to ask, are they made with the same compounds, the same components? All right. So in my data table, I'm going to have numbers. So I'm going to put numbers here. This is going to be 1, 2, 3, and 4, again with pencil. And in my data table, it's going to say that lane number 1 is where I'm putting the Crazy Art brown. And what I'm going to do is I'm going to make very careful dab onto that dot with my ink. There you go. To generate a very small spot. I want to let it air dry for a few seconds. And in the meantime, what I'm going to do is I'm going to bring my Crayola one and dab the dot here at number 2. There you go. While that one dries, I'm going to come back and do number 1 again. Dot there. And while that one dries, I'm going to come back to my Crayola and do number 2. And you probably want to do about 3 of these dabs so you can load a concentrated but small sample of each. There goes number 1 again. All right. I'm sure some of you guys can do even better than I'm doing. And here's number 2. Okay, so that'll do it for the brown. In my data table, it'll say sample number 1 is brown from Crazy Art. Sample number 2 is brown from Crayola. And then what you would do is you would take 2 other inks, 2 other colors, and put them on dots 3 and 4. Let's say, for example, purple, or maybe orange. You want to use like a secondary color. I don't think it'd be worth your while to put red, yellow, or blue, because those are very likely to be made of just one component. Okay, the next thing I'm going to do is I'm going to take my paper and very carefully fold it along the middle. Okay, fold it, don't crease it, because you don't want to break the paper. It's just enough so that it can stand up like that. All right, so there's my samples. Okay, now in this demonstration, I didn't put anything in 3 and 4. We're going to look at just lanes 1 and 2 only. Okay, let's go to our development chamber. All right, here is our beaker that has the solvent that we're going to use to develop the chromatography. Remember, in a chromatography, the chromatography paper itself is the stationary phase, and the solvent is the moving phase. So I had it covered with a watch glass because I didn't want the fumes to bother other people. So I'm going to take it off. Okay, remember there's just a little bit in there, just enough to cover the bottom of the beaker. And here is my chromatography paper sample. Those are, remember, lanes 1 and 2. Those are brown colors from Crazy Art and from Crayola respectively. So what I need to do is I need to put this in the solvent, but I had to do it very carefully. I wanted to enter and touch the solvent all at the same time. So I'm going to very carefully put it in there, bring it down, bring it down, bring it down until it rests in the bottom. There it is. And now I'm going to cover it. And as soon as it hit there, the solvent starts to climb up the chromatography paper. And the development of this will take, essentially just a few minutes. It's already climbing up there. You can probably see it, the shadow there on the video. Let me put it a little closer. All right, let's put it a little closer so you can see it. And now it's starting to hit my samples. And as it hits the samples, it will start separating the components according to their different solubility properties between the solvent and the stationary phase, which is the paper the chromatography paper is made of. After a few minutes, the chromatography has run, and you can see how the different components of each color have been separated. And just from looking at it, you can tell that it is each company is using different pigments, different components to assemble their brown marker. So what I'm going to do now is I'm going to take off this watch glass lid. Very carefully, I'm going to pull the guy out of there. And what I want to do is I want to set it down and let it air dry just a little bit. All right, there's my chromatogram. And I'm going to move this guy out of the way so that I can show you our chromatogram. There it is. And I'm going to let it air dry, and a little bit before it finishes drying, I want to make sure I put a line where the solvent front is. In other words, how far the solvent migrated. And I'm going to put a line there with pencil and a line there. This is going to be important because each one of these spots on the chromatogram have what is called an RF, and that is explained in your handout. And what we'll do later on is we will find the center of each one of these and measure the distance from the origin to the center of that spot. Let's say, for example, this red one here, and divide that by the distance from the origin to the solvent front, and that ratio is called the RF. In the meantime, we're going to let this dry, and we're going to show you other sample chromatograms so that you can see how they are analyzed. Here is a sample chromatogram after drying. And in this experiment, the student was checking the orange and the green colors of Crayola, number 7 and number 9, and Crazy Art, number 8 and number 10. Again, notice that for both the orange and the green colors, the two companies are using different components, right? You can see where the green, for example, in the case of Crayola, is made with some blue and some yellow, as expected. But notice that Crazy Art uses perhaps a different type of blue component and a different type of yellow component. Notice that the yellow component of Crazy Art seems to be the same one that is used to make the orange color, except that in that case it's combined with some kind of like a pink or red. Notice that the Crayola orange seems to be only a single pigment. They must have found a compound that by itself is orange. So what the student has done here is they've identified for each lane what are the boundaries of each spot. Now they're kind of spread out because the resolution that we get on this type of paper and with this solvent is not awesome, but it's good enough. So what we do is we draw a line with pencil around the boundaries of each one of these, and we kind of eyeball where the center is of each one of those. Next, what we'll do is we'll measure the distance from the origin to that particular center of that spot, right here or here. And then we will also measure the distance from the origin to the solvent front, which, as you can see in this case, was 6.65 centimeters. So the ratio of the distance migrated by the center of a spot to the distance migrated by the solvent is what we call the RF. It's a ratio that allows us to identify whether components of different mixtures are the same or they are different. Okay, thank you very much.